Hello everyone. So in this video, we're gonna talk about the Miller indices. So let's work through one example in order to get some intuition about the Miller indices and why do we need it. So let's say we have a 3D coordinate system and we also have a plane that intersect the z-axis at point 3, the x-axis at point 2, and the y-axis at point 1. And we can express this 3D plane by using the plane equation. So in this plane equation, xin stand for x-intercept and yin stand for y-intercept. Zin stand for z-intercept. So the x-intercept of our plane gonna be 2, which is in the x-axis. So we're gonna replace this with 2. And in here, y-intercept gonna be 1. So this gonna be 1. And z-intercept gonna be 3. So 3. So our plane equation after plugging in all the intercept point gonna look like this. So let's check if this equation valid. So let's pick the point over here, which is the intersection between the plane and the x-axis. So the point gonna be 2 for x and z and y gonna be 0. So if you plug this point into this plane equation, you're gonna have x over 2. And since y and z is 0, right? So you're gonna have 0 and 0 equal to 1. So now you're gonna do some arithmetic. Your x gonna be 2. And it's matching this point right here. So this plane equation is valid. And in EE338, this plane equation is not the only way for us to express this given plane. Actually, we also have another way that is more concise and simpler just by using a vector. So let's imagine that we're gonna view this plane on the back of it. So our eye is gonna be right here. So the question is how many vectors that you can make from this reference point to the surface of the plane. So from this point, you can make the vector right here, or over here, or even right here. So basically, you can make an infinite amount of vectors from y-axis to x-axis that can touch the surface of this plane. But we want to choose a vector that's easy for us to construct and represent this plane. So how about we choose a vector that is perpendicular to this plane surface? So it's gonna form the angle of 90 degrees over here. And let's call this vector as v perpendicular. And let's give it a general form. So we're gonna have a perpendicular in x direction, B perpendicular in the y direction, and C perpendicular in the z direction. So this is just an arbitrary expression of the v perpendicular vector. And instead of writing in this long form, you can just write it as the square bracket and then A perpendicular and B perpendicular and C perpendicular. And this square bracket notation is the short way for you to represent this v perpendicular vector in the order of x, y, z. So just with this single vector, you can construct the plane by just drawing the surface perpendicular to this vector. And moreover, this vector can also give you the direction that the plane surface is pointing or heading to. So let's have some other example. Let's say we have a vector that lies in the y direction and it's gonna stop at point 2. So you can call this vector as square bracket 0, 2, 0. Because it's only lying in the y direction, therefore the x and the z should be 0. Now let's try to construct the plane that is perpendicular to this 0, 2, 0 vector. And since it has to be perpendicular, therefore the angle that forms between the plane and this vector should be 90 degrees. So this is going to be the 90 degree angle. And let's construct our plane. And please note that the right side and the left side of this plane gonna extend infinitely. And also, since our 0, 2, 0 vector pointing to the right direction, therefore the face of this plane also point to this direction. So you can see with just like a single vector 0, 2, 0, we can construct the whole plane easily. And since we already used the square bracket to denote this directional vector, so how about the plane? What notation we're gonna use? So we're gonna use the parentheses And inside, we just put the same information of the directional vector, so 0, 2, 0. So this notation means that your plane is constructed by drawing a surface perpendicular to the vector 0, 2, 0, and also the face of the plane point to the direction of this 0, 2, 0 vector as well. And this blue plane right here gonna be called the 0, 2, 0 plane, which is named based on the directional 0, 2, 0 vector. So from this plane equation, you can express it to a more concise and simpler form, which is the directional vector that's perpendicular to this plane. So let's say A perpendicular, B perpendicular, and C perpendicular. And you can also get the plane that is constructed based on this directional vector. So the plane gonna be A perpendicular, B perpendicular, and C perpendicular. Thus, the process that transforms the plane equation into this new notation gonna be called the Miller indices. And the Miller indices give you the direction and the plane. So now let's talk about the Miller indices procedure, or how to transform your plane equation into a much more similar and concise form in terms of plane and direction. So the first step is to identify the intercept point in the x, y, and z axis. And after you find the intercept point, you're gonna find the reciprocal of those intercepts. And lastly, after you get the reciprocal, you're gonna multiply it with the LCD, or the lowest common denominator. So let's have some example. Let's do this first plane right here. So the first step is to identify the intercept. And you can see our intercept gonna be 1 for x, but it doesn't intercept neither like z or y. Therefore, we're gonna have infinite. And because there's no defined value for the case of non-intercept, therefore we're gonna use the infinity value. And the next step is to find the reciprocal of those intercepts. So the reciprocal of 1 is 1 itself. So reciprocal of infinity gonna be 0. So we're gonna have 0. Same thing for here, 0. And lastly, multiply your reciprocal with the LCD. So for this case, there's no LCD. So this is gonna be your answer. So from this, you can say that the directional vector gonna be 1, 0, 0. And this plane right here gonna be called the 1, 0, 0 plane. So let's try this one over here. And the first step is to identify the intercept. So there's no in the x, we have infinity. There's no in the y, infinity. And in the z direction, it's intercept at point 1. So we're gonna have 1. And now find the reciprocal. So reciprocal of infinity gonna be 0. 0. Reciprocal of 1 gonna be 1. Therefore, you're gonna have the directional vector called as 0, 0, 1. And this plane right here gonna be called 0, 0, 1 plane. So let's try this one right here. The intercept point gonna be infinity for x, and 1 for y, which you can see right here, and infinity for z. So reciprocal, gonna get 0, 1, 0. And from this, you can say that your directional vector gonna be called as 0, 1, 0. And this plane right here gonna be 0, 1, 0. So now let's try a more complicated problem, which is this one right here. The first step is to identify the intercept. So intercept for x gonna be 1, for y gonna be 3, for z gonna be 2. And now let's find the reciprocal. So reciprocal of 1 is 1, reciprocal of 3 is 1 over 3, and reciprocal of 2 is 1 over 2. And now we can find the LCD of this case. So the LCD of this case is gonna be 6. So you're gonna multiply those reciprocal with the LCD number 6. So you're gonna have 6, 2, and 3. Therefore, you're gonna have the directional vector, which is the one right here, perpendicular to the plane, and it's in the form of 6, 2, 3. And this plane right here gonna be called a 6, 2, 3 plane. So now let's try this last case, and our first step is to find the intercept point. So there's no intercept in the x direction, it's gonna be infinity. And for y, it's gonna be -1. And for z, it's gonna be infinity because there's no intersection between this plane and the z-axis. So we find a reciprocal, you're gonna get 0, -1, and 0. And there's no LCD, so we're gonna skip the last step. Therefore, our directional vector gonna point in this direction. And here's one thing to note. If you have a negative number, you won't use -1 in the directional notation, but you're gonna use 1 and bar on top. Therefore, we're gonna write 0, 1, and bar on top, and 0. And we have the square bracket outside. So if a number is negative, we're gonna have a bar on top of it instead of a negative sign before the number. And this plane right here gonna be called 0, 1 bar 0 and parentheses outside. So there's one more notation that we need to mention, which is the curly bracket. So what is the curly bracket and how it's different from the square bracket and the parentheses? So the curly bracket mean the set of equivalent plane. So what is the equivalent plane? So as you can see, this is our 100 plane, and both of it, like right side and left side and even top and bottom, extend like infinitely. And basically it's just an infinite plane that facing in the x direction and extended infinitely everywhere. And similarly, this plane right here also have the same shape. It's also extended infinitely. But the difference is like this one pointing to the z direction. But either what direction it's pointing to, the shape and the side is look similar or equivalent to 100 plane. Therefore, you can say that the plane of 100 gonna similar to the 001 plane. So they belong to one set. And also, the 010 plane also has the same shape, like it's extended infinitely everywhere. It's just different direction, the y. So you can also include this into this set right here. So we're gonna have 010 as well. And similarly, this one right here, even though it's pointed to the negative y direction, but it still have the same shape, which is infinitely everywhere. So we're gonna have 0, 1, -0. So you can see this is a big set, like it has 4 items inside. Therefore, we just need to pick one of them to be the representative. So I'm gonna pick this first one, 100. Therefore, the representative gonna be 100. So this means the set of equivalent plane that's similar to 100 plane gonna equal to those set right here. So in summary, those are the notation that you need to remember when you study EE338. And notice that H, K, and L is similar to X, Y, and Z. So the parenthesis notation stands for the plane, and the square bracket stands for the direction vector that's perpendicular to the plane, and the curly bracket stands for the set of equivalent planes in the shape H, K, and L. And lastly, if you have a negative number, you're gonna have a bar on top of your value.